All right, so as I said earlier, today we are going to be learning about the moon. So have either of you learned anything about the moon before, or is this the first time?
We did. Focus much on the moon, but I know some things.
All right, yeah, we're just gonna learn more about it today then. So a satellite is an object that moves around a larger object. So have you guys heard about the satellites that we have around Earth?
Yeah.
Yeah. So it's called a satellite because it's moving around the Earth. And it does different things, such as like taking pictures and recording different things about space and while it moves around the Earth. So the moon is made out of rock. It's mostly igneous. It's the 5th largest moon in the whole solar system, which is crazy because when we think about Earth, we think it's so large. And then we're not actually the biggest planet in our solar system. It stabilizes the Earth and our climate. So have you ever heard of one way that it might stabilize our climate, or like a part of our climate? And you can guess here. It's totally fine if you do not know the answer. Heard before that it actually like the tides. Have you heard about the ocean tides being controlled by?
Yeah.
Exactly. Yeah, exactly. So the tides are stabilized by the moon. That's one example. And so basically the Earth is on this axis and it's like wobbling around. And without the moon there, it would just wobble out of place. But since we have the moon there, it stays in one place and it only shifts slightly because that's what it's supposed to do. So it stabilizes it by making it stay in place and not wobble all over the place. And the moon sits about 240,000 miles away from Earth. That's a long ways away from Earth, isn't it? Have you guys ever driven 240,000 miles? No. The farthest I drive usually at a time is only about, let's say, 5 miles, something like that. So not very far at all. All right, so for our first activity, we are going to be learning about moonlight. We are all going to learn about how sunlight is reflected off of the moon's surface through an interactive activity and how we see the moon on a daily basis. So where does the moon get its light from? If you have any ideas, you could also read off the slide. Yeah. Yeah, Jasmine?
The sunlight.
Yeah, exactly. So moonlight comes from the sun. So the moon itself doesn't actually have any light, but it is just reflecting the sunlight off of itself. And so at night, if it's super bright out, but the sun isn't out, it's still light from the sun, but just reflecting off of the moon's surface. So just like half of the Earth is always illuminated by the sun or like lit up by the sun, because you have day and night, right? And about the same time. So half of the moon. So half of the moon is always lit up by the sun. But we don't always see it that way because of the different angles that the light is hitting the moon, and it depends on where we are on the Earth, and so there's a lot of different things that change that. And so we see the moon illuminated in different quantities, which result in lunar phases. So I'm going to, so here are a bunch or all of the lunar phases that we have. And so imagining that the sunlight comes from here, if you have a completely dark moon, then it would be a new moon. And then as it gets further and further and further and further along, then you see more and more of the Earth. And so it goes to a full moon when the sunlight is fully on the moon. And so we're going to learn and see how that actually works using our own little moon and sun. And so did you guys remember any of the names that I just talked about, or that you've known about before, that you can name either of these?
Yeah. Crescent?
Yeah, so there's actually, there are multiple crescents. Yeah, Jasmine, do you have a specific one?
I also know about the new moon and also the full moon and also the half moon.
Yeah, exactly. So the full moon, would the full moon be this one right here?
The middle.
The middle one, exactly, yeah. And the new moon is actually not shown here, because it would be completely dark, or almost completely dark, because it's starting a new month. So for this activity, we're going to need a flashlight or lamp with no shade, or just like a little light, any ball that can be pierced through with a pencil. So a little styrofoam ball, or a foam ball, or a tennis ball, anything that you are willing to put a pencil into, and then a pencil with a pointed end.
Jasmine. My sister was just substituting for me because I was going to do something. So I got the materials, and I'm not in 3rd grade. She said 3rd grade by accident. I'm in 4th grade.
Okay. Nice to meet you. And great. You have all your stuff. Awesome. So if you could eat any food for the rest of your life, what would it be?
I don't know, actually. I don't really have a favorite food. I like all foods.
Yeah, I agree with you. I like all foods as well. But I was thinking about it, and I really like pasta, and I think there's a lot you can do with it. Do you like pasta?
Yeah, I love pasta.
Really good. All right, so once both of you have all of your materials, then we'll get started on the activity. Oh yeah, Annika, do you have all your materials now?
Is this tennis ball okay for the ball?
What?
Is a tennis ball okay for the ball?
Tennis ball?
Yeah.
Yeah, definitely. You are going to have to put stab a pencil into it though. So if you do not want to make a hole in it, then I would suggest something else. I understand that Monica is getting her materials still, but I'm just going to move on to the first step. So once you have all of your materials, you're going to take the ball, so whatever you found that you're able to use, and to push the pencil or pointed stick through the ball, and then that is going to represent the moon, so the little ball that you found. Tell me when you're all there. Annika, did you find a ball that you could use? No? You can just use a tennis ball, but not put the stick through it. That works too. Yeah. All right, so since both of you have that now, so now you're going to want to turn on the flashlight or lamp or whatever light source you have, and place it anywhere in the room. The best location would be on a shelf or a dresser, and that's going to represent the sun. And so basically you're going to, for this activity, you're going to want the room to be as dark as possible so that the only light source is that small light source that you have. So if you want to go and do that as best you can, I think it says on here, yeah, it says that we should turn off all the extra light that you have in your room, and then try to pull down the shades over windows if possible. Try to make the room as dark as possible so that you can really have the best effect for this activity. And then once you are both done with that, Annika, do you have the tennis ball? Perfect. And if you just try to make the room as dark as possible for this activity, that would be great. And it's fine if it's not super dark, just as long as you can see the light easily on the ball, then that is totally fine. So after we turn off all the lights, then we are going to stand a little distance away from the quote-unquote sun, so your light source, and then we're going to hold out the moon and keep it approximately at the same height as the light source that you had, the flashlight or lamp or whatever you choose. Let me know when you're all ready. Maybe just a thumbs up or if you have a flashlight or a little lamp or something, and then your tennis ball. Great, okay. So as I said, now you can get up and stand about 5 or 10 feet away from your sun or flashlight, lamp, whatever you have as your sun, and then hold out the moon or the ball or styrofoam and keep it about at the same height as the sun. And then, so you represent the Earth. You represent someone standing on the Earth looking at the moon during its different lunar phases. So from here, you're going to try to turn slowly around the moon to see how it changes and to see all the lunar phases that you would see if you were a spectator on Earth. And trying to make sure that your arm is in the same place so that you really can see those same phases, and so that you don't see the same phase in 2 different places by accident. So you both can get up and do this now if you want. To get up and stand with the ball at about the same height as the light source, but maybe a little bit further away. Then like move around it to see the different phases that you would see for the crescents. And you can let me know if you have any problems or any questions or anything while you do this. But this activity is just, yeah?
The flashlight is not really good right now, so I'm not able to see the light on my ball.
Okay. Well, if you could, I bet you can imagine what it would do. Just imagine if the light source is at your camera, possibly, and then you can like move around and see, oh, from this angle, only that part's shaded, so it would be a half moon. Or from this angle, oh look, it would be full moon because the full light is on the ball. Or from this side, none of the light is showing, so it would be a new moon. So that is just supposed to represent the different phases of the moon that you would see. All right, so if you are able to do this, or just imagine it, you're going to create a couple different lunar phases by rotating yourself and the ball. So try to make a full moon. So a full moon is when the light is completely shining on the whole surface of the moon. So you can move around and see the whole moon. And then possibly the third quarter moon. So you would have to be, which side of the light source would you have to be on for this? If you were looking at the light source, which side would you have to be in order to see the moon like this? Light source, you would have to be on the left of the light source with the moon in front of you in order to see the light shining on the left part of the moon, and then have the rest of it be dark so that you see this third quarter moon. What about the waxing crescent? What would you think for that? Which side of the moon would the light be on for this? The left side or the right side? Or the top or bottom? Have any guesses?
Right?
Yeah, exactly. So the light would have to be on the right. But you would have to be sort of at an angle where you are closer to the back of the moon, and but you still see a little bit of light from it. Exactly. So what did you notice about how the moon changed as you rotated around the Earth?
Well, I noticed that the light and the shaded part of my ball was changing each time I rotated it.
Yeah.
It's like the different phases of the moon.
Yeah, exactly. So, and did you notice that that's similar to what you actually see for the moon on a daily basis? Do you ever pay attention to what the moon looks like, or see, oh look, it's not a full moon, but there's a little bit of light showing, and now you understand why that happens? Yeah, good. There we go. Okay, now we're going to learn about moon craters. So, do either of you know what a crater is? Yeah, what is it? Any ideas?
I don't know how to say the meaning.
Yeah. So we are about to learn about it, but they are basically like holes in a space, and we're going to learn specifically about lunar craters. So we're going to be familiar with moon craters and create your own various using various sized rocks. So lunar craters are formed when asteroids, or like little pieces of rock, or meteorites collide with the surface of the moon. So lunar is specifically talking about the moon, but there are craters everywhere. There are craters even on Earth, made from asteroids and meteorites. But as you can see, like there are little holes in the Earth's surface from getting hit by these rocks. And the moon has over 5,000 craters. So there's a lot of craters on just the moon. And Do you have any idea why Earth does not have as many craters?
Because not many meteorites or asteroids hit Earth.
Yeah, but there's a specific reason for why they don't hit Earth, is that we have something called an atmosphere that the moon does not have. So the moon is practically outer space. When you're standing on the moon, it's outer space. But when you're standing on the Earth, you're protected by a lot of that atmosphere. And so the atmosphere blocks out those asteroids and meteorites from even going within the area that it could possibly hit Earth. But the moon does not have that, so there's nothing stopping these rocks from hitting the moon. And Earth actually does have some craters, but it has water and other environmental like plants and things that cover them up. So you can't see them as much, but on the moon there's none of that, so you can easily see all the craters. So how the craters form, the impactor, or the rock itself, collides with the moon's surface, sending a shock wave out from that point. So the hole gets gets bigger, and the shock wave breaks apart the moon's rock, and that's why there is the actual hole instead of just like hitting and bouncing off. It like sticks and it destroys part of the surface. And then the impactor, or the rock that actually collides with the moon, shatters into tiny pieces and potentially even vaporizes, or it like blows up and does not stay on the moon. But usually there's just tiny pieces of rock that go all over the Earth from that impact. Like from the rock that hits the moon itself, it shatters into pieces and spreads out across the surface. So definitely let me know if you have any questions while I go through this. So now we're going to talk about the specific parts of a crater. So the parts of a crater, you have the floor, which is the bottom part of a crater. You have the walls, which are like the sides, and they're usually like angled, so they're not like straight up, and they're not, it's not just flat, but there's like a outward curve. So imagine if you have the bottom here, and then you have the outward curve all around. That's like that, or like a little steeper, but it's never just straight up. You have the rim, or the edge of the crater. So the very top part of the walls is called the rim. You have the ejecta, or the rock materials that is thrown out of the crater from either the surface of the moon or the rock that actually hits it. Whatever goes out of the crater is called that ejecta. And then you have a ray, which are bright streaks that move away from the crater that are actually made of this rock material that's thrown away from it. And so for this activity, we are going to imagine that a cake pan or tin is a crater. And so for this activity, you're going to need one tin or pie pan or cake tin. You're gonna need a little bit of flour. You're gonna need some sprinkles. You're gonna need some cocoa powder or hot chocolate mix, just like a dark mixture that you can have on the bottom of all along the cake pan. You're gonna have 3 rocks of different sizes or shapes, a lot of newspaper or paper towels, 1 spoon, and then you don't need this, but a sifter, if you know what that is. It's like a very, very thin, like a very, very thin, what is it called? Like a drainer, or like a strainer, sorry.
I don't think I can do this project because I can't do things in my room, and right now in my room I can't bring food to my room, and I can't move my computer because right now I'm in very low battery.
Okay. Maybe you can just try this afterwards then in the kitchen if you want. But I mean, just you can also just imagine it. I'm sure you have a great imagination, so you could think about what it's going to do. But I would highly suggest trying it afterwards in the kitchen so that it's much more clean, because it's very fun to try it yourself and see what happens. So once you all have this, we're going to cover the surface that you're working on with paper towels or newspaper so that it doesn't go everywhere. And then you are going to want to take the pan or tin and cover it with about with a little layer of that flour, so you can pour a little bit in and like flatten it out, make sure it's covering everything, even the sides of the tin, and then so once you finish that, and Jasmine, you can if you can just like try to remember this, or even if you want to like write it down or something, what you're supposed to do. But I'm sure you'll know what to do to try it afterwards, because I highly suggest that you try it afterwards. So once you cover it with that flour, then we are going to use a spoon to create a very thin layer of sprinkles. Do not cover the entire surface. Like less than even 1 spoonful of those sprinkles is totally enough. So once you finish with the flour, then you're just going to take a little bit of sprinkles, put it all over, spread out across the flour. So yeah, once you have the flour, then you just take a little bit of sprinkles and put them all over. With that, then we are going to use a spoon or a sifter if you have one, but you can definitely just use a spoon. Create a very thin layer of cocoa powder or hot chocolate mix, just enough to completely cover the surface of the pan. Yeah, very small amount. That, so you do the sprinkles and then a little bit of the cocoa powder or hot chocolate mix or dark powder that you have, a thin layer of that across the whole thing. once you finish with the cocoa powder, then you're going to do the actual activity for it. Is it all good? All the cocoa powders or hot chocolate mixes across the pan? Not quite? All right. Okay, once you are finished with that, or I'm going to show you the next step that you're going to do. So once you finish with that, then that's basically your moon. And so to make those craters, we're going to take the couple rocks that you have and drop them one at a time into the pan or tin. And they come out better when the rock is dropped from a greater height, but if you do not want it to splash or to go everywhere, then you can do it from a little bit of a smaller height, and dropping them at different angles, and everything makes it a lot more realistic. This is just to see the effect that your rocks, or the asteroids in this case, have on the moon's surface. Yeah, look at that. That's awesome. Okay, so as you can kind of see, for those, this is just an example of a crater on the moon, and so it points out the different parts. And so you have the floor, the wall, the rim, and the ray or ejecta. So did you see that for your own experiment?
I can't see the ring.
Say again?
The ring. I can't really see it.
Yeah. So it might be a little harder if the rock is still there, but also if you take the rock out, then you can look at all the parts of the crater. Usually when it hits the moon, the rock is no longer there because it breaks up into pieces and goes all over. But if you move the rocks, then you can see those different parts, right? Yeah. So how did the size and weight of each of the rocks impact the craters, and how did the height or angle that you drop the rocks from impact the craters also? And even Jasmine, you can answer this if you have a prediction, even though you didn't do it. I'm sure you can.
The height. I think it made much more of a crater.
Yeah, definitely. Like as the rock gets bigger, and as you drop it from a lot higher of a distance, it makes a bigger impact. Exactly, and more ejecta gets thrown everywhere, and the crater's bigger, and makes a bigger impact on the moon in this case.